Good morning, everybody joining. Thank you for joining our webinar. Hi, I see Corin, Kevin, Leslie, Stuart, Vino. Hi, everybody, welcome. While we're waiting for everybody to join, won't you please be so kind, tell us in the chat which company are you from and what it is that you do and where you are. That would be lovely to hear from everybody, and then we'll start the session. Hello, everybody still joining. While we're joining and waiting for everyone, please just let us know where you're from, what it is that you do. That'd be great. Fantastic. All right. Okay, we are going to, while we're waiting for you to let us know where you're from, we're going to kick this off. Good morning. Welcome to the Safehouse webinar. My name is Irma Karsten. I'm involved with helping Safehouse with their marketing, but I will be handing you over to our wonderful host this morning, Mr. Connie Jonker and Marthinus Smit, who will talk us through dimmers and LEDs. Before we get going, I'm going to ask both of them just to introduce themselves, and then we will start our session. So please, if you will, Dr. Marthinus Smit, just introduce us to yourself. Thank you.
Good morning, Emma. Thank you very much, and good morning, attendees. Very welcome to the webinar. I'm Marthinus Smit from Shuttle Lighting. I've been involved in technical product management and product development and manufacturing for the past 24 years.
Thank you very much. Connie?
My name is Connie Jonker. I'm operations manager from the Safehouse Association. My background is compliance testing, certification schemes, regulatory models, and laboratory accreditation field. I've been with SABS for more than 40 years and also spent some time in the circuit breaker industry as a certification manager. And I am, with my team, running the Safehouse Association.
Fantastic. Thank you, Connie. And on that note, Connie, I'm going to ask you to just do an introduction for us to Safehouse in a moment. Just for everybody, a bit of ground rules. We will handle, or our hosts will handle your questions at the end of the webinar today, because we think some of your questions may be answered through the presentation. This webinar is recorded, so the recording will be made available afterwards. So if you do have to drop off a little bit earlier, you are welcome to. You will have access to the full recording after the session. But once again, welcome to everybody. Thank you for joining our webinar today. It's going to be very, very informative and helpful. And with that, I'm going to ask Connie to just do an introduction, and then we'll start straight with our presentation thereafter.
Thank you, Irma. You have seen the Safehouse logo. That is a new logo which actually says what we are doing. Safehouse, the power to protect. We are an association of voluntary electrical industry stalwarts. And we have the common mission to only supply products that comply with standards, regulation, and specifications. Now, there are a variety of regulators, the NRCS, the Department of Labor, regulating the installations industry. And we have found that over years, the NRCS regulatory model is very restrictive and ineffective. And that actually set the focus of Safehouse. Instead of just negotiating and liaising with the NRCS, we realized that we have to focus on a branding system of Safehouse members' products where they can claim compliance. So we tend to go to make a move to self-regulation, because in the end, it's the supplier, the manufacturer, or the reseller's responsibility to be responsible for the compliance of its products. Within the Safehouse group, we have a surveillance model where we have a peer review. We accept complaints from our members about products, then we investigate, and if it's one of our members, then they are obliged to take appropriate corrective action. If it's a non-member product, then we would report this to the NRCS for further action. We are also establishing a compliant product database where our members can log the products that they claim compliance with. And that database will be part of our website, but it will be accessible to consumers, contractors, product developers, and so on. Part of the focus of Safehouse is also to educate our members, but also the public, because we find that there's little knowledge about the regulations, the specifications, the standards, how to go about setting up procedures for self-compliance, inspections, and in-house testing. Yeah, I think it's a very big market out there, and we try to also accommodate other associations where we can affiliate with and work together to this goal. The next slide, please. So our mission is to facilitate the industry to self-regulate in parallel to the regulatory model. The regulatory model, because it's ineffective and very limited, self-regulation is an alternative, and I think it's the way to go. The fourth one is educating businesses and consumers about safe products. From time to time, we send out mailers or we have guides on certain products. And the webinars that we hold is the next focus that we do on certain topics that are of interest to the consumers, but also to the suppliers. Thank you.
Very much, Connie. And without further ado, I'm going to hand you over to Dr. Marthinus Smit. Thank you very much.
Good morning, Emma. Thank you very much, and welcome everybody to our webinar. Today we're going to focus on the basics of dimming LEDs. And prior to 1960, dimming was a very, very expensive technology, and it was reserved mainly for stage and theatre lighting. Then in 1959, Mr. Joel Spira, very, very clever gentleman who later formed the well-known Lutron company in America, invented and patented the first commercial, let's say, residential dimmer. And interesting marketing strategy, they marketed basically to the housewife at that stage with a message that she can create the ambience in her house. Very, very powerful message, and I think it's one of the messages that still remains very valid, besides all the technical benefits and electrical benefits of dimming LEDs or dimming lamps, like increased lamp lifetime, energy savings, and so on. It's the only technology which can actually provide you with a very dynamic control of the ambience in your living environment, in your entertainment environment, in the consumer environment, restaurant environment, literally at the touch of a switch. So from 1960 up to about 2010, before the coming of age of LEDs, there was essentially no problem with dimming. You bought a lamp of any brand, halogen incandescent lamp, and dimmer of any brand, and it simply worked. Then around about 2010, in more closely 2012 in South Africa, LEDs started becoming mainstream products to the consumer and general market. Now, with the new technology came fantastic new features and benefits and so on, but also oddly additional problems. And it's these problems that we are going to address today. And because of just trying to find out how to forward. Suddenly my screen doesn't want to forward. There we go. So yes, because we have a wealth of information, practical experience we gained over years, we actually tailored this webinar specifically to address some of the problems and some of the questions that we get mostly out there. And obviously, this is just a condense of a lot of information, and anybody that wants more information, welcome to contact us anytime. Our information and our assistance are always free of charge. So we're just going to have a look at how LEDs dim fundamentally, then going to look at phase cut dimming, and then we look at the relationship between LEDs and dimmers and how to address that and so on. As I mentioned, sorry, my screen is a bit delayed. As I mentioned, we're focusing mainly on phase cut dimmers. That's the residential type of dimmers. And here's a small example of what some of these dimmers look like. Before we go into dimming and the problems there are related to that, it's very important that we just have a basic understanding of how LEDs dim. Now, it's a bit of a it's a bit of a strange concept sometimes for electrical engineers if they hear somebody say, I have a dimmable LED or non-dimmable LED, because it's actually, strictly speaking, incorrect. You must say dimmable LED lamp or a non-dimmable LED lamp, because any LED, and I'm referring to the light emitting diode, the actual component that you can see in the yellow wave, in the yellow here, these components. That's the LED component. Now, any LED component is fully dimmable. The LED component operates on a constant DC current, whereas halogen incandescent lamps operate on an AC or DC voltage controlled. Now, because the LED component requires a constant DC voltage, a constant DC current, it actually requires what we call a driver to convert the power supply, whether that's a 220-volt mains, whether it's a car battery, whether it's a 12-volt power supply, into a constant current. So it depends whether your driver that's associated with a lamp, whether it's built into the lamp or whether it's external, is designed to be dimmable or non-dimmable. That makes your LED lamp dimmable or non-dimmable. So how does your LED component dim? It's actually very, very simple. It's like opening the sprinkler on your lawn. The more current into the LED, and obviously the more water flow current, which is also unidirectional, so it's a DC flow of water. The more water is on your garden, the more light there is, and the less current, the less light there is. So there are two popular ways of controlling that amount of current which goes into your LED lamp. Firstly is the analog dimming, which essentially just changes the amplitude. It's like adjusting your tap slightly to get a slightly better flow or a slightly lower flow. The second, now the advantage of analog dimming is that it's very, very affordable. It's a technology which is used in most of your G10 lamps, your A60 lamps, and etc. The advantage of that, like I said, it's very small, it's cost effective. Disadvantage is that it may be sensitive to fluctuating supply voltages, which we'll come to later, and it may not offer that deep dimming. So that is where digital dimming, digital control comes into play. It's essentially where your LED component receives a very constant current. Imagine that your tap is fully open, and you just close your hose, you just bend your hose pipe, and you control the flow of the water by opening and closing the hose pipe, or the bend in the hose pipe. So your LED will receive pulses of currents, and if there are little pulses, the average current into the LED is very low, and you have a low intensity. And if there are more pulses, more condensed pulses as well, you have more light output, because your average current is much higher in your LED component. This type of dimming is reserved mainly for your external drivers, because it requires much more electronic components. It's much more difficult. It is much more accurate. It provides you with a very, very low dimming, and typically more robustness against fluctuating supply voltages. There are some disadvantages, and you find that some of the high-end drivers from your especially from your traditional European manufacturers, actually combine analog and digital dimming in certain cases. Now, because we concentrate on phase cut dimmers today, just a quick introduction here. If we look at the waveform on the top left-hand side here, this is a beautiful sine wave. That's what the voltage looks like when it comes out of your main supply. Now, importantly, I've encircled the crossings where the voltage crosses from positive to negative in red here, and when the voltage crosses from negative to positive again in red, because that is where your dimmer actually synchronizes with your mains. Your dimmer has to be very, very, very synchronized with the AC mains, and we'll get to that as a problem a bit later. And in leading edge dimming, as you can see in the second waveform here, when the AC voltage crosses through zero, initially the dimmer leaves the lamp off, and then somewhere in the cycle the dimmer would actually turn the lamp on. Now that provides a sharp inrush of voltage and sharp inrush of current into your lamp and into your dimmer. And that's why, if you think back to the old times when we had the rotary dimmers on the wall, you can often hear a buzzing sound in in the dimmer and sometimes in the lamp as well. And that's because of the sharp inrush of voltage and current into your lamp or into your dimmer 100 times a second. Pardon me. Now, this dimming technology has been the status quo from 1960 up to around about 2005. Then trailing edge dimming started becoming more popular, and with LEDs now as a necessity. Trailing edge dimmers are much more natural for the lamp because in a trailing edge dimmer, the dimmer actually turns the voltage and the current on into the lamp as the AC crosses through zero. So for the lamp, it's a very, very natural, it's a natural soft start every cycle. And then there's just a turn off somewhere in the cycle, which is much less stressful for your lamp, although there could be stresses which we'll come to a bit later. So that's the fundamental differences between leading and trailing edge dimming. Now, nowadays, trailing edge dimming is the default which we encounter. So if we look at the problems which we encounter with LEDs and dimmers, the most common problem, the most common question is what is the maximum number of LEDs that I can place on my dimmer? Then we see a lot of problems with minimum dimming intensity. We find lamps which turn off prematurely. We find lamps which do not all turn on at the same time. You get a pop on and pop on effect where one lamp turns on, the other one might later turn on, don't turn on, and only as you increase the intensity, all of them turn on. You sometimes get a very non-linear dimming characteristic where you turn the dimmer down and you think the dimmer is broken because nothing happens, my light is staying bright, and then suddenly you see the lamp dimming down. You get lamp ghosting. That's where your lamp still stays on while your dimmer is off. And then an emerging problem which we see is where the lamps in the same dimming circuit do not all dim the same. This is an interesting problem which we'll address in detail a bit later. And then probably the most difficult problem that you encounter out there is lamp flicker, or lamp shimmer, or lamp pulsing. Now, why do we get these problems and why didn't we have it before? The main reason for that is because there's currently still no national or international specifications for dimmable LED behavior or for dimmer compatibility. There's no testing procedures, there's no standardized procedures. Even the very latest VC 9109 from National Regulator, which is, I think it's coming into effect in May next year, combines a whole lot of technical specifications, lamp efficacy, the chromatic properties and all those kind of things. But on dimming, and I'm reading it off from that specification now, it only mentions in one small sentence, says, statement on dimmability. Clearly state whether dimmable or not dimmable. If yes, the information on dimmer compatibility must be provided. That's it. So we have thousands and hundreds of thousands of LED manufacturers, different electronic circuits in it and so on, and hundreds of dimmer manufacturers, and they actually don't know how to talk to each other, officially from a specifications point of view. That's the one problem. And then the other problem is that there's a continuous evolution of LED technology, and with that evolution comes new driver types and new driver characteristics and so on. A good example of that is a couple of years ago, it was unimaginable that you can actually get a filament LED lamp and have a driver built into that very small base, and yet we have it, and we saw a new driver type emerging there. Now, unfortunately, because of that continuous evolution in LED technology, the number of manufacturers and so on, as well as the lack of specifications, your dimmer actually has to evolve dynamically with your lamp. So your ideal dimmer requirement is that your dimmer must be adjustable to ideally suit all your lamp behaviors. And that is also a very dynamic thing. It changes the whole time. We prefer digital settings because it can be done after installation very easily, and it's easy to assist the end client to do settings if required. Now, a couple of years ago, when you mentioned that that the dimmer is programmable, the market would actually shriek away and say it's very complicated, and they don't want that. They just want a simple thing which they install and walk away from it. But that time has actually passed, and the majority of installers actually realize the benefit of programmable dimmers because it actually solves the problems in the field dynamically, and it's becoming the accepted norm from international manufacturers to have dimmers with a lot of settings in it. So the question regarding the number of lamps per dimmer, this is one of my favorite slides of all times, and says not all 5-watt LEDs are created equal, and these are all measured waveforms. Now, even if you don't understand the waveforms, just pay attention to the yellow waveforms. The yellow is the current, lamp current. These are all measured results. The red waveform is the voltage. applied to the lamp, and you can see in all cases the voltage is exactly the same. It's a 230 volt AC. In the lower right hand corner, you can see a 50-watt halogen lamp. You can see that the yellow waveform, the current, is actually, it looks exactly the same as the voltage. It means that this lamp has a unity power factor, 100% power factor. And then if you start looking at the various LEDs, now this is just a small example. There are much more different waveforms, but this is a nice representation. You can see that your LEDs have quite different waveforms. LED 4 and 5 incidentally do not meet the MC standards, but you can intuitively feel that the number of lamps and the dimming behavior of these LEDs must all differ. So the factors that determine the number of dimmers per lamp is firstly is your lamp power factor, your startup inrush current. Then you can have a turn off current peak. If the dimmer has a soft turn off to it, which provides that natural fade off, we found that there are some of the LED drivers, external drivers, which has built-in power factor correction, which actually then produces a sharp turn-off current peak. Your steady-state peak current, which is called your press factor, plays a role, and then whether it's on leading or trailing edge dimmer, and then your lamp can also have a dynamic characteristics which changes depending on what the intensity is. So as an example of this is a typical 7-watt waveform of a typical 7-watt LED. And you can see the yellow waveform once again. There are stages during the AC waveform where the lamp actually draws no current. In fact, the full current requirement of the lamp is condensed in 20% of the AC cycle. And the peak of the current here is 200 milliamp, which is equivalent to 46 watt. So this is a 7-watt LED. So you can see that you cannot simply take your LED dimmer or your dimmer rating and use it as your determination of the number of lamps per dimmer. So how do you do that? The CE recommendation and recommendation from the large companies overseas, your European companies, your Philips, Levons, Osram, and so on, is that you must use the replacement wattage of your lamp to determine your electronic transformer and your dimmer rating. So that's why you'll see that on the box of your LED, it will always be printed what the equivalent halogen rating is. So for instance, if we look at a 5-watt LED, let's say its equivalent rating is 70-watt halogen, it means that you can only place 7 of those LEDs on a 500-watt dimmer, because 7 times 70 watt is 490 watt. Now, this is the official recommendation if you have no idea what your dimmer or what your lamp behavior is. Because this is very limiting, a lot of manufacturers, dimmer manufacturers, and even lamp manufacturers supply compatibility charts. Now, interesting, this is our own chart, our own in-house measure chart. This is a small example of more than 700 lamps that we have tested. This is a snapshot of some of the 5-watt LEDs, and you can see some of them are recommended for leading edge, some of them for trailing edge. And you can see that the maximum number of lamps differ significantly according to model and according to brand. Now, this is not an indication of lamp quality. It's purely a result of how the driver is designed. So, next problem that we encounter is that, and this is a very common problem, is that the LEDs don't dim down far enough. Now, your dimmer typically has a minimum intensity and a maximum intensity. Pardon me, the factory default. The IC recommendation, which SAP has adopted, is that the minimum intensity, pardon me, of your dimmer must be such that there's still a faint glow in a halogen or incandescent lamp. But we do find that many LEDs, pardon me, are still fairly bright when the dimmer is at minimum intensity. So your dimmer must be able to simply set its minimum intensity. So you can see here, we set the minimum intensity to lower than factory default. Then we find that some LEDs flicker when they are dim or when they reach a minimum intensity. It's interesting that many of the lamps are designed for European conditions, are not designed to dim so low, and we do find that sometimes you get a low end flicker, and we also find that some of the lamps actually turn off completely when the dimmer is still very bright. That is a very common characteristic of especially your filament lamps. So in that case, you must be able to set your dimmer minimum intensity to higher than factory default. Then it's it's a rare occurrence, but you do get some LEDs which flicker at dimmer maximum intensity, and we still can't really figure out why that really happens. But it's very rare. But there may be a requirement from your lighting specification that your maximum intensity must be limited, or even, for example, in a baby's room. And then the other problem that you sometimes find, as we mentioned earlier, is a non-linear dimming characteristic of some of the LEDs. We find that as you turn the dimmer down from maximum, the light essentially stays exactly the same, and then at a stage it starts dimming down. So in all these cases, you can actually set your maximum intensity to avoid these conditions. So in the case of the non-linear lamp, you can start dimming down until you visually see that the lamp starts dimming, and then just set your maximum intensity. That makes the dimming curve much more linear. So ideally, you must be able to set your whole dimming window of your dimmer, and that address the maximum intensity, minimum intensity, lamps flickering, and etc. Now, a problem which was very common up to about 2018 was lamp ghosting. That's where if the lamp stays on when the dimmer is still off. Now, phase cut dimmers without a neutral, which is the most popular type of dimmers in South Africa as well as abroad, typically has a standby power consumption when the dimmer is off of about 0.5 watt, but then you get your ultra efficient models, which brings that standby power down to about 50 milliwatts. And it's incredibly little. It's about 200 microamps maximum. But we do find, and it's not common, but we do find that there are still some lamps which, even at 50 milliwatt of standby current, have a slight light output. We find that mostly on your 220 volt LED strip lighting, where it essentially where the driver in there is essentially just a resistor. And unfortunately, from the driver point of view, there's not much that can be done about that. But if you use a trailing edge dimmer, it's very easy to solve that problem by simply installing what they call an EMI capacitor. It's a pretty cheap part. It costs R4, and you install that anywhere in the circuit across your load. Now, I apologize. I see that I was supposed to have a very nice pulsing light here, which indicates my light, but somehow the technology didn't work with me. The solution works, and it's been field tested, and the beauty of the capacitor, as opposed to a dummy resistor, which some manufacturers or some dimmer suppliers recommend, is that the capacitor actually doesn't heat up, and it's very safe to install that. Now, this is a very interesting problem, that we find that there are some lamps in the same dimming circuit that do not dim the same. Now, because the lamp dimming behavior can differ significantly between brands and even between different models within a brand, it's always recommended that you install only one or the same model of lamp in your dimming circuit. But what we have found now recently is that even if people install the same model of lamp in the same dimming circuit, there is still an inconsistent dimming behavior. So we analyzed that problem, and these are once again measured waveforms of the same model lamp. The yellow waveform is the voltage. You can see it's the same the whole time. And then the purple waveform is the lamp current. And you can see the different manufacturing batches. The top left hand is an older batch. You can see that the driver purple waveform has this wave shape. Then on a later build, you can see that the wave shape changes significantly. And then on the latest build, you can see that the wave shape is once again completely different. Now, just by looking at the wave shapes, you can just imagine for yourself that the dimming behavior would be quite different. Now, unfortunately, the only indication of the difference between lamps is simply the date manufacturing code, which is printed on the lamps. The lamp model remained the same. So if you encounter this type of problem, especially with G10 lamps and some A60 lamps and so on, please ensure that all the lamps in the same dimming circuit are from the same manufacturing batch. That's very important. Now, lamp flicker, shimmer, and pulsing. That is a very complex problem, and a very involved problem with many different causes and many different solutions. Like we said earlier, many lamps are not designed for very low dimming, and they may flicker. And in that case, simply set the dimmer's minimum intensity slightly higher to avoid that situation. some voltages, some LED lamps are very, very sensitive to small fluctuations in the difference between the positive curve and the negative curve when you start dimming. You know, that if we think back to the waveform of the leading and trailing edge dimmers, as I showed earlier, where the dimmer synchronizes on the red dots where the voltage crosses from positive to negative, and then from negative to positive again. We do find that some UPSs and inverters has a slight ripple, very, very, very slight. Otherwise, the waveforms are beautiful, but at the zero crossing, there's a slight ripple. So the dimmer has no other way of knowing what the AC synchronization information is, but simply to look at the zero crossing. So the dimmer may, in certain cases, synchronize slightly earlier and slightly later. Now, those differences may be as little as 0.2 milliseconds, which is really, really nothing. But some LED lamps are sensitive to those very small fluctuations, and you do get lamp flicker or shimmer. Now, in those cases, we recommend that the client experiment with different lamps. Typically, the lamps from your traditional European suppliers or European brands has much more what we call capacitance into the lamp, and they are more robust against these fluctuations than some of the later lamps are very sensitive. So experiment with different LED models. A mains filter may solve the problem, and the jury is still out on that one. Sometimes it works, sometimes it doesn't work. And then in extreme cases, if you encounter this problem, especially in restaurant environments and so on, the easiest or the best is to change to a bus technology such as a 1 to 10 volt control, which is very much immune to any such problems. Now, the last problem that we see on lamp flicker and shimmer is a very interesting problem, and there's actually very, very little information out there. So we embarked on a investigation and measurements and so on, and we found that there are some lamps which are very, very sensitive to fluctuate. The lamp intensity is very, very sensitive to fluctuating supply voltages. So I'm just looking at my time here. I'm still good. So these are now measured results. We took 6 LED lamps, 6 LED filament lamps of different brands, and we measured its light intensity, the actual lux or lumens. We measured that at 230 volts. As you can see here in the middle, at 0, there's my reference intensity. Pardon me, now this is without a dimmer, it's on straight mains. So we changed the supply voltage from 230 to 225 volt, which is only 2% difference. And you can see one of the lamps intensity changed by 25%. If we change the voltage to 235 volt, which is also just 2%, the intensity changed by nearly 17%. That's at 100% without a dimmer involved. Then if we dim down to 30% intensity with a trailing edge dimmer, we can see that the picture changes quite a lot. And most of the lamps exhibit at least a 5% change in intensity when you fluctuate the voltage from 230 to 225 or from 230 to 230 volt. Now 5% intensity when lamp is at 30% intensity, pardon me, is quite visible, and you can see it with the naked eye. If we dim down to 10%, we can see that the picture changes quite significantly, and most of the lamps samples that we tested show a fluctuation of more than 15%. That is very, very significant. You can see it with the naked eye from a far distance. This is a summary of the results, and you can see that at 10% dimming, the total intensity swing of the lamp across the -2% and +2% of supply voltage. You can see here sample number 3 was 65%. This is quite significant because you can actually see it now that you're aware of the problem. If you sit in a restaurant and they have filament LED lamps, just observe it for a while, and I promise you can actually see at stages, you can see the lamp dipping and flickering, and sometimes you see a shimmer and so on. And that happens when your supply voltage changes just a small bit when a kettle turns on, when an air conditioner turns on, when they turn on the equipment in the restaurant and so on. Typically, if you plug a normal household kettle into your supply voltage or into the mains, you turn it on, your supply voltage in a house or on that circuit can actually drop easily with 2 or 3 volt. So this is unfortunately due to the LED lamp technology designed with a driver design. And once again, we come back to the lack of specifications when it comes to dimming and so on. And the resolve of this problem is rather difficult. We see that this problem is now not only limited to filament LED lamps, it's spilling over into GU10s and A60s and so on, as the driver design which is used in the filament lamps are adopted into your smaller lamps as well. So unfortunately, a filter will not solve that problem because a filter can typically not filter out such a big difference in your main supply voltage. So a way to solve it is to use an automatic voltage regulator or a UPS or something similar, or then you can use a dimmer with a special proprietary settings, which actually monitors the lamp intensity and stabilize the lamp for that. Some other problems that we encounter is that some LED lamps, and strange enough, we found over the years that LED lamps which are designed in Ireland are very much leading edge favorable. So some of the LED lamps are designed for leading edge only, and you must then be able to set your dimmer for leading edge, and it also helps with fault finding. Very importantly, inductive loads, especially with LED lamps, such as transformers and so on, we still do find that out there because there's retrofits from old installations and they change to 20 volt LEDs, and invariably in a dirty seating somewhere somebody forgets to take out the Y1 transformer. Now that huge inductive load can actually damage your trailing edge dimmer, and in cases it can also cause damage to LED lamps. So in that case, a leading edge dimmer must be used, and ideally your dimmer must be auto sensing. We also find that some electronic transformers for low voltage LEDs, in the cases where it's still being used, like in zone 1s in wet environments and so on, sometimes we find that the electronic transformer doesn't turn on, especially at low intensity or when the dimmer starts up, although the minimum load condition requirement of the electronic transformer is abide to. In that case, it's ideal to have a dimmer which has special setting, which actually provides a turn on kick pulse for the electronic transformer. So in order to solve the majority of problems that you encounter in the field, the ideal behavior or ideal characteristics of a dimmer must be that it must be able to auto-detect your inductive loads. You must be able to set your minimum maximum intensity. You must be able to set your dimming curve, your dimming speed, especially if you use a bell press dimmer. It must have a setting to start up your electronic low voltage transformers. That pop-on effect of some LEDs at low intensity, you must have a setting to address that. You must be able to ideally turn if the dimmer has a soft turn off, that fade off effect, you must be able to turn that off and provide a sharp turn off to avoid that current peak in some of the drivers, as we discussed earlier. Nowadays in South Africa, load shedding is becoming is the norm, and many people require different behaviors from their dimming circuit when the power returns. Some people want the dimmer to always remain off. Some people want to come on to minimum intensity, and etc. So ideally, your dimmer must be able to adjust that power failure behavior. Like I said earlier, it must be suitable for leading and trailing edge dimming, and then ideally for the emerging problem of where the lamps are very sensitive to supply voltage fluctuations, the dimmer must have some sort of a setting to actually address that. Now, we do find some other problems as well. One of the interesting ones that sometimes crops up and requires a lot of measurements to determine what the reason is and so on, is that we found that some dimmable external drivers, although the lamp and the driver are ideally matched, we do find that there's a flicker occurring at low intensity, or it doesn't turn on at low intensity. Now, the reason for that is, let's say we take a LED lamp which requires 700 milliamp current maximum, and its output and its operating voltage range is 8 to 12 volts. So we select a driver 700 milliamp with 8 to 12 volt operating range. But now let's say we dim to a low intensity, or the dimmer starts up in a soft start, which then provides an increase in the voltage. And let's say at that low intensity, the lamp draws only 10 milliamp. The voltage may be much less than 8 volt, which the lamp sees at that, or which the lamp requires at that stage, and your driver cannot provide 8 volt. So the solution there is to always make sure, if you use a dimmable driver for dimming, make sure that your driver voltage range is at least 10, pardon me, is at least 10% lower than the lamp specification. So in this case, rather use a 6 or a 7 volt driver than an 8 volt driver. Now, lastly, and this is also becoming very, very important, because of the load shedding in the country, many companies and many people are moving over to inverters and so on. And very often we find that the contractors do not really pay any attention, or the installers do not pay any attention to the lighting requirement when they do the load calculations and so on, because the logic is to say that, if I have 10 8.5 watt LEDs, it's 85 watt. It's nothing compared to the geyser, which is 2.5 kilowatt and so on. But it may not be correct. So yeah, once again, measured waveforms. This is just to show why you must never use a quasi-sine or simulated sine wave on especially dimming, and in my opinion on LEDs as well. This is a measured waveform of a UPS, a quasi-sine wave UPS, which is available in the market, and you can see that it's actually not even sine wave. It's a block wave. And the red waveform here, you can see that the peak voltage, where's my mouse? Peak voltage here reaches close to 400 volt. And with only 85 watts of LEDs, you can see that there's a 2.6 amp inrush current into the UPS. So I'm not going to spend much time on the current crest factor. That just says what is the ratio between your peak current and your RMS current. But most of your inverters are designed for a crest factor of 3 to 1. Now, if we look at that case now of the 8.5 watt LEDs, you can see here on a true sine wave, this is the yellow is the waveform if you have no dim installed. And then if you have a leading edge domain installed, you can see that your crest factor goes up to 11.8, which means immediately you're far exceeding the ratio of 3 to 1 for your inverter. And you can see that the measured current waveform here shows that you have a 13 amp current peak, which your inverter has to supply. Now 13 amp, that is, what is that? That is 2.5 kilowatt. Whereas if you dim that on a trailing edge dimmer, you can see that your crest factor comes down to 2.2, and you have a 0.3 amp peak current from your or into your inverter, 46 times less. So when it comes to inverters as well, and solar inverters and so on, do pay attention to your dimming requirement and your LED requirement, because it can actually catch you very, very unaware. So just to summarize, and I think my timing is absolutely perfect. There are many problems that we encounter with dimming LEDs. The problems are not going away. The problems are, in our opinion, actually increasing as the variants out there and available in the market are increasing. The key is to make sure that, firstly, when your LEDs are fully dimmable, ensure that you use the same models on the dimming circuit. Remember that not all controls work on all dimmable LED lamps, so make sure of what the manufacturer specification says. Speak to your dimmer supplier. Find out what is the maximum loads that you can place on the dimmer without causing damage to the dimmer, or causing the dimmer to shut down. Some LED lamps are created better than others, so make sure that your LEDs lamps are fully compliant to the national and international specifications, and work with your reputable suppliers, obviously, and exactly the same from the dimmers. Currently, it is legislation that any dimmer, whether it's manufactured in South Africa or whether it's imported, must have a national regulator LOA at present, and so always make sure of that. And in the case where you're not sure whether something will work together, rather consult with your LED supplier or your dimmer supplier to do some testing for you, and ideally, if you can, do a mock-up before you go to site. that was a lot of information, and there's obviously a lot more information which we can supply. So please feel free to contact us afterwards as well if you need any information. But I hope that this very rapid condense of a lot of information was of benefit to somebody. But I'll gladly take some questions.
Thank you, Marthinus. This was a really informative session. We have a question from Shelley James. That was while you were talking about the lamp boasting. Question is, there are lots of legacy lamps out there. Friends and family are often asking me about these issues. Is the only solution to replace the whole circuit? That was a question from Shelley. I typed it in the chat for you as well.
I think I see it in the chat. I'm not sure what is meant by legacy lamps. Is that halogen or incandescent lamps? In the case that it is halogen or incandescent, the power consumption lifetime on those lamps are so little. Old LED lamps. Actually, no. If the lamps are still working, you know, it's good. If the lamps are dimmable, then even the latest generation of LED dimmers will actually dim that. You know, there's these in the case of our dimmers are universal, so it's fully backwards compatible, even with old electronic transformers. All the lamps that has been manufactured, to the best of our knowledge, on dimmable lamps and so on. So it's if one of the lamps in the circuit fail, then it's going to be, and it's a dimming circuit, then it's going to be very difficult to actually find something which matches that characteristic ideally. And in that case, it would be possibly be better to replace the whole circuit. I hope that answers the question. Okay, Shelley, please take my details and contact me afterwards. We have and I'm sure we can actually help with the popping, with flickering and ghosting.
Marthinus, we had another question from Connie. With the different wave shapes of LED lamps of the same model number result in different light output values and lumen maintenance characteristics.
Mr. Jonker, thank you very much for a very complicated question. Yes and no. I can't really comment on the lumen maintenance because, to the best of my mind, the suppliers know what the RMS current into the LED component is, and irrespective of what the waveform of the driver is, the maintenance should be the same. That is in my mind if I would do that design. But the light output when one starts dimming differs very significantly. Any other questions?
I don't see any other questions. All right. If not, thank you, everybody. I'm going to paste a few links for you in the chat. Please feel free to read more about what Safehouse membership entails and how we can help make the electrical industry safer in South Africa. I'm putting the link in the chat for you now. You are also very welcome to reach out to either Connie Jonker at Safehouse or Marthinus Smit at Shuttle Lighting. But we want to thank you very much, everybody, for joining. We value your time and we hope it was informative. We will be sending you links to the recording and also the presentation file after the session. Anything else from either you, Connie, or Marthinus before we close this off?
Thank you much, Emma. Thank you very much for everybody that attended. Hope it was of benefit, and I wish everybody and their families a very blessed Christmas season and a prosperous 2024.
Yeah, I would just like to thank Marthinus for doing the presentation. In the new year, we will be doing some more on topics across the electrotechnical industry. And thank you very much for joining, everybody.
Thank you. Before we go, Andre, was that a wave or was that a hand to ask a question? Not sure if you were raising your hand to ask a question or if it was a wave. Okay, I think it was a wave or a thank you. Thank you, everybody. And we look forward to see you in our next webinar session. We will be hosting a few sessions in 2024. Have a safe holiday season, and we look forward to see you in 2024. Thank you so much, everybody. Take care.
Thank you.
Thank you.